that AE is congruent to AD and that FC is congruent to FB. And all of that is our given information. Let's make sure that all of that is marked on the picture. The fact that FD is congruent to AB, or not, is perpendicular. FD is perpendicular to AB is right here, this 90-degree angle. That shows that that's perpendicular. And then FE being perpendicular to AC is marked right here. And then AE being congruent to AD is marked right here. And FC being congruent to FB is marked right here. Our goal is to prove that the whole triangle ABC is an isosceles triangle. We're going to start by looking at those triangles that are right triangles, because that was part of our given information. We need to say that triangle AEF and triangle ADF are right triangles. And the reason that we know that is because of the definition of perpendicular. And you could put this symbol. If you don't know what that symbol means, then write down perpendicular so that you can remember that. So now we've stated that those are right triangles. The next statement I'm going to make is that AF is congruent to AF. And that is the reflexive property. Now I've determined that those triangles, so triangle AEF and triangle ADF, actually, we'll just put that they're congruent. Those are congruent. And the reason that we know that is the hypotenuse leg theorem. So now we know that those triangles are congruent. Because we know that those triangles are congruent, I can actually determine that EF is going to be congruent to DF. So EF is congruent to DF. And the reason that I know that is CPCTC. Those two legs are the other legs of those right triangles. So because the triangles were congruent, then we could determine that the extra pieces were congruent. We also can determine that triangle FEC and triangle FDB are right triangles. And the reason that we know that is the definition of perpendicular, because if FE is perpendicular to this line, then this is also 90 degrees, right? So we can just call that the definition of perpendicular. So we know that those are right triangles. And then we can actually say that triangle FEC is congruent to triangle FDB, because again, we have the hypotenuse being right here and a leg right here, hypotenuse leg. So we have the hypotenuse leg theorem. I'm going to rewrite that so it looks more like an L instead of an angle sign. And then we can say, going back to that picture, we've now said that these two triangles are congruent, which means that this piece right here, we're going to do 1, 2, 3, 4, 5 markings there. We can say that CE is congruent to DB, and that is by CPCTC. I'm going to go back and look at this picture just a little bit more. Now I can say that AE is going to be congruent to AB, and the reason for that is the angle addition postulate. AC is congruent to AB, angle addition postulate. We can add those pieces together. And then our final statement is that triangle ABC is isosceles, and that is just the definition of an isosceles triangle. Because an isosceles triangle has two equal sides, and that is what we just proved. And go ahead and make sure you can see this all on the screen at one time, just so that if you need to view that better, you can. Go ahead and pause your video here and do the try it, and come back and check your work at the end. While your video was paused and you were doing your try it, you should have gotten that try it filled out. However, I do want to pop back up here. I did accidentally write the wrong thing here. That should not be angle addition. It should be segment addition. I get going too fast sometimes. I apologize. Caught my own mistake. Fixing it like that. Here is the answer to the try it. Hopefully you follow that, and if you had a different series of steps and you still have the correct logic, don't panic. There is often more than one way to complete a proof.